Well, hi, good morning, and thanks so much for joining me here in my shop. It's today is August 24th. So, you know, when you watch my videos, you're watching absolutely real reality TV, right? I'm not making any of this stuff up, and whatever happens, I tend to put out on video. Sometimes I'm putting out mistakes I'm making, and I don't realize it at the time. I find out later. It all goes out. I don't edit it away. So when you watch my videos, you gotta kind of grip your seat a little bit. So, how many mistakes did I make? I made a pile of mistakes here. First, I forgot I pulled out the rectifier tube. So, if there's any question about why the oscillator doesn't oscillate, that may be a reason. I pulled it out because the part of the circuit I'm working on doesn't involve the sweep oscillator directly. But the few times I have checked to see if the oscillator is there, there's been no rectifier tube in the set. Okay, that's a bit of a mistake. Mistake B, looks like I put the diode in backwards here. When I put a diode in to replace this rectifier, no matter how much magic I try to use on myself so I won't get the polarity wrong, it seems like I almost always get them in backwards. And I'm going to attribute this to my life journey, where as a kid, you know, playing around with electronics and stuff like that, I understood everything in terms of electron flow. That's what was in my head as I learned everything. When I went to college, I was stunned to find out the college I was going to, Ryerson University, they taught current flow, the opposite. And frankly, I don't think I ever recovered. I don't think I ever recovered from it. So, right. So I've switched the diode around, and to try to convince myself I've got it right now without having connected completely. It's just one end is connected, the other end's hanging open, hooked up to my voltmeter. Well, I'm going to see if my voltmeter goes positive or negative. And there's another mistake in here. A lot of the voltage measurements I've been making, especially when I'm using this guy, I've had his ground wire, just like I do now, grounded to the chassis, while I'm working on a circuit which is independent from the chassis completely. This is why I got the funny volt readings. You know, I should have realized this. I should have realized this. You know, you see the voltmeter go up and then come down as if the voltmeter is draining a capacitor. Yeah, pretty tough to drain a large capacitor with a voltmeter like this. I should have realized right then what was really happening is I'm charging up and discharging a smaller capacitor. Okay, anyway, I won't get into that because I think I'm about to say something wrong, so I'm going to stop there. So let's see if I can sort these out one thing at a time. First, so it could well be that the problem is this rectifier was shot, and if I'd only done everything right and put the rectifier in, the unit's working again. Boy, I tell you. Sometimes I think this work would be a lot easier for me if I wasn't here. Okay. So we're going to make the voltage measurement. Now this time I'm going to measure the voltage on this meter, using this meter. And it's going to be read between the diode output, which should be positive, giving a positive reading here, and a negative side of the same circuit, not involving the chassis and the rest of this unit. So flip it on. See the meter go positive, rejoice, take my tail out from between my legs, carry on. Here we go. Let's see if this is going to go that way. Is it going to go that way? Is it going to go that way? So voltage I'm supplying here is restricted to 50 volts and dim bulbs. And there you see, a positive voltage there. Jim, oh my gosh. You know, let me just show you something I was looking on the internet as I was trying to sort out positive from negative. Look, this is clear in my head. It always has been clear in my head. The arrow points in the direction of conventional current. Electron current goes the other way. So you just got to make sure you're thinking right. You must make sure you're thinking right. How do you do that? I don't know. Clearly, I don't know. Well, let me just take a moment. I'm going to show you something off the internet here. So there's lots of sites on the internet where they're trying to help people like me figure out which way is which with a diode. You know, there's only two ways too. I mean, it's crazy. So here's a place where they're trying to help you out. Got a nice diagram here. Somewhere they pointed out that the K side, the cathode side, looks like a K, and that's how they remember it. You know, I remember this stuff really easily. It's easy for me. Conventional current flows in the direction of the arrow. It's as simple as that. Just remember that. Conventional current, the holes go that way. The electrons flow against the arrow. And I've got this in my head very, very firmly. Look at the statement they made here. The cathode is the electrode that vomits out positive charge. And the anode is the electrode that sucks in positive charge. No, there's no sucking and blowing with a diode. But you know, people are trying their best to get this straight. So I guess I'm not alone in this. Here's another confusing thing. If they put this on here, you can study this for quite a while. I believe the diagram is perfectly correct, but you know, they didn't do little things like put the plus and minus on these terminals and stuff like that. Plus terminal, current flow goes this way. Electron flow goes this way. Oh look, they even put it here. Direction of current of positive charge. Okay. And then there's a whole raft down here. All this stuff down here is people giving their ways of remembering which is which. Look at this one. Think of cats. A lot of people think cats are bad. Bad is synonymous with negative. And that's why the cathode side is also the negative side. That's the way I was taught by my professor. For me, I'd have trouble remembering that cats are bad because I think cats are good. So, yeah, all kinds of memory aids here for this thing. Well, I wouldn't be honest with you if I didn't tell you this is the third time I've tried to put this into my video. Each time making a ton of little video mistakes here this morning. So anyway, here we are. Cathode symbol. Look at this. Now there's many websites that try to help you learn how, you know, how these things operate, what the polarity is. For me, it's the easiest thing in the world. I've never had a problem with this in my own head if left alone. For me, as I was taught in college, current flow goes in the direction of the arrow. Electrons go against the arrow. That's it. It's done. There's no complication after that. Look at this statement. The cathode is the electrode that vomits out positive charge. Actually, it vomits out positive charge. The anode is the electrode that sucks in the positive charge. Oh my God, are you kidding me? There's no sucking and blowing with a diode. Okay, you know, wow. But I guess this might be helpful to somebody. It wouldn't be helpful to me. And if we come down here, there's a nice little diagram here. And it shows, you know, off the positive terminal of the battery, current flowing in the direction of the arrow. See? Direction of current of positive charge. Electrons going the other way. And then down here are a whole bunch of sort of memory aids that people have. They're sharing down here in the comments. I'm going to read one of them to you anyway. This one here. Think of cats. A lot of people think that cats are bad. Bad is synonymous with negative. And that's why the cathode side is also the negative side. That's the way I was taught by my professor. Well, good luck on that. I don't think cats are bad, so I'm off. I'm already backwards. I'm already backwards on this. So many other crazy ways of remembering it. But the way I remember is very simple. Current flow follows the arrow. Electron flow goes against it. That's all. That's all. Okay. Now, despite my ability to read that stuff and despite my knowledge that's firmly in my head, I still manage to get these guys in backwards quite regularly. So this guy's not backwards anymore. Okay, and another thing too is I did make a video error and did a little session here without the video actually recording, and that's why this capacitor is out now. So I've taken out the big one from here, I've taken out the slightly smaller one from here. I tested this. This is supposed to be 16, it says right on it, 16 microfarads. This tests at close to 30. That's not good. It shouldn't test that high. That's probably indicating this is a little bit leaky. And likewise for this. This guy I tested, I don't know if it's on video anymore. I gave him a test, he passed the test with flying colors. And since the alternative to this one is an even worse looking one, which also tests with flying colors, I might as well just leave this one in. So I'm going to change these two electrolytic. And I don't know, see, I don't know if I mentioned this or not, but did I mention about me forgetting to put the rectifier tube in? So in the last video I made a test to see if the oscillator was oscillating. It wasn't oscillating. Well, there's no rectifier tube, there's no B+ for the oscillator, there's nothing. Duh, 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 duh. I did say something yesterday, didn't I, in the video about I felt like I wasn't thinking straight. I don't know if I ever think I'm thinking straight. Okay, so now I got everything straightened out. Let's stick some capacitors in there and see if this thing doesn't come to life finally, despite me. Okay, we're ready to check it out here. Now just a comment here. You know, I do my best to not do unnecessary work. I think all this might have been unnecessary. All based on my initial false measurement of the output voltage coming off the original rectifier. Because I had my meter grounded to the chassis, which is totally inappropriate for the test I was doing. So that false indication, which didn't make sense to me at the time either, is what drove me forward to doing all this and getting into a bit of a schmozzle with it. The fact is, I'm better off without this rectifier anyway, I'm pretty sure. He says before he tests it and finds out, no. There's something special about those rectifiers that a diode won't match, and I don't think there is such a thing. Okay, I'm going to plug it in here. We're going to plug in the rectifier tube. Now, a good thing to do would be find that tube. Where is the rectifier tube? Normally put off to the left, but then, you know, normal. Okay, I don't know what I did with the rectifier tube. What the hell? Son of a gun. Okay, gotta go hunting for a rectifier tube. Coffee break time anyway. Okay, found the tube hidden behind, just hidden on my desk right here. Just out of sight. Let's put it in. Hey, should we operate this without this tube first? No, let's be bold. Let's try the whole thing. Because this unit did work until I started doing stuff to it. Then it stopped. How will we know if it's working? Well, let's do the simplest one of all, and that is, does it put a signal onto a radio? Let's find out here. I kind of like that approach. Okay, put my radio over here. This is the output here too. Everybody stand back. Switch is on. So last time I switched this on fully, we got just the full dim lights over here. Maybe that's going to happen again. Okay, so we're plugged in. We're ready to hit the switch here. Just hesitant for a moment. Okay, let me just go over this quickly. So diode's in place. Capacitors are connected. This capacitor is reconnected. There's no test equipment connected. Yes, there is. This thing. Yes, my misleading meter ground connection. It's a really good place to connect it, but no, it wasn't. Okay. And that's on the antenna. And let me turn the radio on. Now it's at 100 hertz. 100 megahertz. This guy is set close to there on the sweep frequency. The marker amp is switched off. So if anything happens, it's got to be from the sweep. The sweep is set, sweep width is minimum. And when you set the sweep width minimum on here, it should actually go down to a single frequency. There shouldn't be any sweep left, apparently. Okay, we're ready. Ready as I can ever be. Watching the dim bulbs. Nothing happened at all. Oh, right, we've got it down at 46 volts here. Okay, so I'm going to crank it up to the proper voltage. This is on output. The dim bulbs are not showing anything. It's a little odd. Panel light is on. Rectifier tube's heated. Okay, I'm going to tune it. We'll see if it pops out of this radio. Fingers are crossed. Wrong band. Ooh, band D. Okay, here we go again. Crossing the fingers. Come on, man, come on. She's a no-show. It's a no-show. Okay, so that's unfortunate. What we could try now, while this is operating, is look for a voltage on these capacitors of some appropriate amount. What appropriate amount? So is the current flowing in the primary of the Increductor? That's what we want to know. So once again, I'm going to make a grounding error. No. So this meter is isolated from ground, so it's safe to use. I wouldn't want to use I wouldn't want to use this kind of meter in this scenario. You know what? We're only feeding this with 87 volts because I got the dim bulbs going. That's unusual. Let me check the wattage here as best I can. Well, so this is a 40 watt unit. Isn't that what it said in the manual? Let's say 40 watts. Power requirements, 50 watts. Okay, 50 watt units. 50 watt unit. So 50 watts is just a little higher on this meter. I'm going to take out the dim bulbs. God help us, here we go. Okay, so it's 55, 50, 60. It's about 60, but the output voltage may not be right. Output voltage is right on the money, pretty well. Okay, so we're running a little high here on the wattage. So we should watch out. No, are we getting anything on the radio? Is it working now? Come on, come on, come on! Attenuator, attenuator. She's a nothing. Lower band, a half of 100. So 50 is found on band C. Anything? Come on, radio. Nothing. Nothing coming out. Nothing. Attenuator halfway. Negatory on all that stuff. Nothing smoking. Nothing getting hot. So far. What about this coil? I don't know if I'm touching the right areas. Don't feel any heat. This is cold too. What about this guy? What's he doing? I think this guy is an additional transformer to supply 6.3 volts to the additional tube that we are so far away from now. Still not working. Okay, I was going to make a voltage measurement here, and then I got distracted away. Put the negative lead of my voltmeter on the negative or ground point of this whole circuit. And this lead I'm going to put, this should be the positive charge. What are we on? 200 volts there. 155 volts. That sounds correct. If you took a halfway rectification, you can get up there as long as you don't draw any current. You can get all the way up there. So that's the right. That's the right. That's the right. Now, there should be some amount of current going through the primary of the Increductor. What if I turn on the sweep? How's that going to do anything? Or remove the sweep. Don't turn it on. It's on all the time. So if I have it sweeping fairly wide, and we get anywhere near, and D anywhere near 100, you should hear it. Nothing. It's pretty convincing it's not working. So probably what's happened here is some event has taken place between when I started working on this and now, much earlier on, that caused the sweep oscillator to stop. I thought the event took place in this little circuit I've been working on for 2 days. No, I was the event in that case. So whatever it is that stopped the sweep from sweeping is still in there. And one of the things that's in here is a bunch of older capacitors, but you can see every time I test them, they test really good. This guy tested really good. This guy tested really good. Maybe not good enough. Okay, so I got to think about what to try next. We're still drawing just a little over 50 watts here, which is probably fine. We have 113 volts on the unit. We don't need to listen to the FM radio because it's just telling us things aren't working. Yeah, so it doesn't take much to stop an oscillator. It just takes a guy like me. I gotta go away and think now what my next approach is. Okay, a little bit of encouragement from one of my mentors and my own thoughts on this. So the oscillator here is not oscillating, and this is to amplify the oscillation here and to kind of isolate the effects of the output from the oscillator itself. The oscillators can be quite fragile. Everything has to be kind of right for them to go. So when I look at that oscillator circuit, back up on the grid, we find a capacitor there. And if we look over here, this 10 ohm resistor going to a fairly, relatively large capacitor, 0.01. And then tucked up here is another one hidden right in there, connected to the grid of the amplifier part of this arrangement coming from the grid. So you kind of connect the grid of the oscillator to the grid of the amplifier. So I'm going to try to find and replace these 3 capacitors here, since they seem to be in a precarious sort of position. The grid is a sensitive thing. That's what I really want to say. So I'm going to try that. These are ceramic capacitors. Normally I don't find ceramic capacitors in the old stuff that I work on. But when I do come across them, I trust that they're good. I have found bad capacitors, not dilapidated ones, but open circuit and shorted, very small ceramic type capacitors over the years. But normally, no, they're great. So we'll try to find this. This one I already know where the 0.01 is. If we look up here, in this part of the circuit, this is the oscillator tube, the 6BQ7. Well, there's one right there, jumping out at me. It says 0.01. Yeah, all 3 of them right here, by some chance. All 3 of them right there. That could be. This one says 47 on it, and this other one says I can't quite read it, but I'll bet you that's the other one too. Those are easy to get to. Okay, so I'm gonna replace those. Yeah, and we'll see what happens. I'll test them too when I take them out. What I've got here is a mess of capacitors, and I'm trying to locate exactly the correct capacitors to replace the ones up yonder here. It's not going well. So what I'm going to do is, I've got a 0.01. I can replace the 0.01 with exactly the correct replacement. I'm going to do that and hope that's the problem, and the others can be left for now. Otherwise, I'll be replacing them with sizes that are slightly different from what's in there. It's an oscillator, and I'm not too happy about that. So that's what I'm going to do. So I'm going to take this guy and replace the 0.01. For what it's worth, I have a lot of doubt about this having any effect on it, because usually I find those little capacitors extremely reliable. But let's do it. Okay, one capacitor in. This is the old one. Yeah. Well, 10 nanofarads. That's 0.01. Well, I really doubt this is going to make any difference, but let's give it a try. Anyway, once again, just looking for the output coming right out of it. Here. There's my FM radio going. A little safer here before I turn it on. Okay. That's a little better too. There's tools that are here. Okay, my friend. What are you going to do this time? Okay, so find attenuators in the middle. We're on ×1 on the big attenuator. We're on band D, which has 100 megahertz on it. Radio's tuned to 100 megahertz. New capacitor in. Away we go. Give it a moment. Sweep is set to minimum. The marker generator's off. Okay, I'll tune it. Come on, radio. No, there's nothing there. Nobody home. What if it's there, but so weak? I kind of doubt it. Okay, so, yeah, no. Yeah, no. Not working yet. Okay. Okay, hold on a minute. I'm running this unit again. I'm running it through the dim bulbs. Only 87 volts. That's a mistake. Let's turn it up full power. Okay, here we go again. Show up. Nope. Band C at 50. What about a lower band? Anything. Harmonics may. No, there's nothing happening here. Nothing happening here. There's nothing to see. Another day of I don't know, of what? I don't know. Getting back to square one, I think. So thanks a lot for watching. I noticed the number of viewers going down, of course, because this is a complicated thing, not interesting to most people. Most people want to see radios getting fixed and stuff like that. So those of you who are hanging in here and watching, thank you very much. I appreciate the company. I got a couple of emails encouraging me to keep going, because this is an unusual device. I've never been exposed to it. And in fact, one of the emails said, takes a licking and keeps on ticking. And that's kind of what you got to do here with this kind of stuff. So, okay, that's it for today. I'm off to enjoy the beautiful weather we're having here today. What am I doing in my shop? See ya.